By the end of this video, this tiny MEMS microphone will be recording audio directly on a Raspberry Pi. And the interesting part is, you don't need to write any code for the ICS43434 microphone itself. We will simply wire it up, configure the Raspberry Pi, and record our first audio clip. Let's get started. First up are the connections, and they are actually pretty simple. I'm using a Raspberry Pi 3B Plus, and yes, I know it's an older model, but the newer ones are, well, expensive. Let's wire everything up. The VCC pin of the ICS43434 goes to the Raspberry Pi's 3v3 pin. Ground goes to ground as usual. LR pin is connected to ground to select the left audio channel. Next, the WS or word select or left right clock, whatever you call it, that pin connects to GPIO 19 or BCM 19. SD or data out pin goes to GPIO 20, BCM 20. And finally, the SCK or bit clock pin connects to GPIO 18 or BCM 18. Once the wiring is done, it's time to power the Raspberry Pi. Now, a lot of people use a power adapter with USB cable, but I have found that setup to be a bit unreliable power source. Though I haven't tried the official RPi adapter. Anyway, so instead I prefer to use this 5V SMPS that can supply up to 5 amps. And I have simply soldered its DC output wires to the underside of the Raspberry Pi. Yes, wrong case, I know. Ordered the RPi 4B one by mistake. Moving on, let me power it up. Alright, now to actually interact with the Raspberry Pi, there are two common ways to do that. You can either connect a monitor over HDMI or you can use SSH from another computer. I'll be using SSH, so let's open the command prompt on my Windows machine. Let me enter the SSH command followed by my Raspberry Pi username and IP address. Enter the password and we are in. The first thing we need to do is edit the Raspberry Pi configuration file that controls the hardware interfaces and device drivers. So let's navigate to boot/firmware directory and open the config file. Inside this file, make sure dtparam I2S is on and also verify that param audio is turned on. Then add Google Voice Hat device overlay. Now you might be wondering why we are using Google Voice Hat drivers. Well, these drivers were originally developed by the Google AI Voice Kit, which uses a stereo microphone configuration. Interestingly, the version 1 AI Kit used the ICS43432 MEMS microphone, along with the MAX 98357A audio amplifier. Almost similar components to what we have been using throughout this audio series. Google later released a version 2 kit, which switched to a microphone from Knowles. One more change before we are done is let me disable HDMI audio so that the voice hat sound card becomes the primary audio device. Saving the file, and it's time to reboot the Raspberry Pi. As expected, session gets disconnected, and after waiting for the Pi to boot back up, let's try to reconnect. Now I will use arecordl command to list the available recording devices. Perfect. We can see our sound card listed as card 1. Let's inspect its hardware parameters. The audio format is signed 32-bit Little Endian. Driver is configured for 2 audio channels, which again comes from the original stereo AIY voice kit design, and the default sampling rate set here is 48 kHz. It's time to configure the audio device. For that, we will edit the system-wide ALSA configuration file located at etc/asound.conf. There's also a user-specific configuration file called .asoundrc, but in this video we will use the system-wide one. Now, what exactly is ALSA? Think of ALSA as the middleman between your applications and the audio hardware. Whenever an application wants to record from a microphone or play audio through a speaker, ALSA is the layer that communicates with the hardware. Let's quickly go through the configuration file. The first section defines the hardware device itself. Things like the card number, which is 1 in our case, the device number, audio format, sampling rate, and the number of channels. The next section configures the software volume control for that same hardware device. This is also where the supported minimum and maximum gain values are defined. Finally, we set this microphone device as the default capture device. That's it. Saving the file, and we are done with the most time-consuming parts. Now let me launch ALSA Mixer. A terminal interface opens up. Press F6, select card 1 RPi sound card, and then press F4 to switch to capture view. Here we can adjust the microphone gain. The available range comes from the limits defined earlier in the configuration file, and I'll set mine to around 6 dB. Press escape to exit and save these mixer settings using this command. Time for action, that is recording real audio. We will use the A record command again. Here I am selecting mic SV device, which points to our microphone hardware. The format is S32LE. Sampling rate is 48 kHz. C2 here specifies two audio channels. Our microphone is still mono, but the Google Voice Hat driver expects a stereo capture, so the recording is saved as a two-channel wave. We will see what that looks like in a moment. The recording duration is set to 10 seconds, and finally we give the name of the output wave file. Let me hit enter to start recording. Namaste Ram Ram. This is an audio sample for Raspberry Pi. And that's 10 seconds. Let's check whether the file was created. Perfect, it is there. Now I just need to copy this file to my main computer and listen it back. For that I'll use SCP, enter the Raspberry Pi details along with the source and destination paths, and start the transfer. Done. Running a quick check on desktop. Alright, okay. Time to open the file in Audacity. Notice that this is a stereo audio where one channel carries our microphone data while the other is essentially empty. Let me play it. Namaste Ram Ram. This is an audio sample for Raspberry Pi. Awesome. Our audio has been recorded successfully. And with that, we have got the ICS43434 MEMS microphone working perfectly with the Raspberry Pi 3B+. I hope this video helped you. If you are new here, be sure to check out the rest of the videos in this audio series. Please give it a like, share it with someone who might need it, and don't forget to subscribe the channel. This is Avinashee Tech, signing off.